Hi there and welcome to our lecture on measuring motion. This is going to be section 1 of our motion unit, and that is unit 5. Our key ideas for this unit: how is a frame of reference used to describe motion? What is the difference between speed and velocity? And what do you need to know to find the speed of an object? And how can you study speed by using graphs? So to start looking at the first question, when an object changes position with respect to a frame of reference, the object is in motion. So motion is defined as an object's change in position relative to a reference point. And we define frame of reference, a system for specifying the precise location of an object in space and time. Look at this a little bit more here on this slide. Distance will measure the path taken, and displacement is the change of an object's position. So we've got one person that's graphed on this soccer field, and they're kind of shaded here, so it shows this individual running all the way almost completely around the soccer field. So this path that this individual takes is displacement. And to know that this person even moved, we'd have to have some kind of reference point. So maybe we have the goal here as a reference, initial reference, saying, oh, the person was standing there, and we can see as they move around the field, maybe we can look at the lines to tell that they're moving. Whatever we use, we have to have something to compare their motion to, something that we would consider maybe stationary. So this yellow path is the individual's distance, and then the black line is the displacement of the individual, how far they were after they ran around the field at the end of their run from the beginning of their run. So displacement is defined as the change in position of an object, and this does include a direction. So we would say that perhaps the individual is so far east from where they started. So again, the yellow line on the soccer field is the distance. The black arrow is displacement, or how far they are from their starting point. So what's the difference between speed and velocity? Well, speed tells us how fast an object moves. Velocity tells us the speed an object moves, but it also tells us the direction that the object is moved as well. So speed, the distance traveled divided by the time interval during which the motion occurred. We're used to seeing this speed measured in miles per hour. So we say miles per hour. In physics or science, we tend to use meters per second, or maybe we use kilometers if it's a longer distance per second. We could use kilometers per hour as well. So these would be longer distances, or maybe a slower vehicle over a longer distance. We tend to use the meters per second for our purposes. And then the velocity of the object is just taking the speed. So looking at the units are the same. Oops. So meters per second. But then with velocity, we were saying, oh, maybe they move east for example. East or down or left or right. But our units are still the same in meters per second. And we tend to use these almost interchangeably. The only difference is direction with velocity. Velocity is also described relative to a reference point, so we need to know where we start and finish. A direction is described as positive or negative along a line of motion. Typically we use up and to the right as positive, left and down as being negative. And then combined velocity determine resultant velocity. Let's look at this up here just really quick, positive or negative. So if we were to make a coordinate plane, or where we have a little graph where we've got an x and y coordinate, anytime we move to the right or up, it's going to be positive. If we ever move down or left, it becomes negative. And this is just some conventions that we use in physics to indicate whether something's moving in a positive direction or negative direction, either up or down, left or right. So we see on the speedometer how to read speed, miles per hour, meters per second, kilometers per second, kilometers per hour. So this particular slide, what do we need to know to find the speed of an object? We have to know two quantities. We have to know the distance they traveled and how long it took them to get to that distance. So if we look at the units, meters per second, meters is distance. This is a distance measurement, and seconds is a time measurement. So we need to figure out those two things to figure out the speed. Average speed is calculated as the distance divided by time. So if we have a graph and it varies over the whole graph as far as the speed changes, if we want to figure out average speed, it's just going to be your average distance divided by the average time. So we define speed as being equal to distance divided by time. We can abbreviate this as v equals d over t. Sometimes we use s here. A lot of times we throw the v in there, indicating that we want velocity, so we want to know direction as well. Again, the units are meters per second. Constant speed is defined as equal distances and equal amounts of time, so we don't change our speed over a certain unit of measurement, say. Instantaneous speed, it's kind of like our speedometer. If we were to take a picture of it while we're driving down the road, which probably isn't a good idea, but take a picture of the speedometer at any given time, that tells us what our instantaneous speed is at any given point. So it doesn't take into consideration how fast we were going at the start or how fast we ended up going, just at a certain point in time what the speed was, instantaneous speed. Alright, so let's look at a math skill here. We're looking at velocity. Metal stakes are sometimes placed in glaciers to help measure a glacier's movement for several days. In 1936, Alaska's Black Rapids Glacier surged as swiftly as 89 meters per day down the valley. We want to find the glacier's velocity in meters per second, and we want to include direction. Before we do that, notice that it said they placed a stake. So we've got this reference point to help us indicate that movement occurred. So we had this stake that was placed in here. Alright, so we're going to list our given and unknown values. So we're given that time is 1 day. Distance is 89 meters down. So we have a direction. We've got down the valley. It's a general descriptive term, which is fine. We can still use that for velocity. So we want to measure velocity in meters per second and how what the direction is. So to find velocity in meters per second, the value for time must be in seconds. So we have to take our 1 day and convert it to seconds. So we have 24 hours a day. There's 60 minutes in an hour and 60 seconds in a minute. So what we've got here is a conversion between days and seconds. So we cancel our hours, cancel our minutes, so we take 24 times 60 times 60. So we get 86,400 seconds. We can change this to scientific notation. So we've got 8.64 times 10 to the 4th seconds, and all we did was move the decimal over 1, 2, 3, 4 spots to get this scientific notation number. So we've got our time in seconds, so we want to figure out our speed or the velocity of this glacier. So again, we're going to put in our known values. What we want to find is velocity. Took us a distance 89 meters. We're dividing that by 8.64 times 10 to the 4th seconds, and then we're going to include direction afterwards. So what happens is when we divide these two numbers, we end up with 1.0 times 10 to the negative 3rd meters per second, and we're going down the valley. If I was to write this number out, this scientific notation number, -3 says that I move the decimal to make this a smaller number. I'm moving it over 3 spots. So did I get that right? 1, 2, 3, yeah. So this is my number in decimal form as opposed to scientific notation. Again, I'm still in meters per second in the down direction. So how can we study speed? By using graphs. You can plot a graph showing distance on a vertical axis and time on the horizontal axis. Again, vertical is the up and down. Vertical is up and down. Horizontal is the left and right. So we think about the horizon. Okay. So we're going to study motion by using a distance versus time graph. Time again is on the x-axis. We also say this is the independent variable. Distance is on the y-axis. This is the dependent variable, and it depends on what time is doing. And then the slope, once we connect the points, so we're going to make a line graph, we're going to connect those points. The slope of this is going to give us speed. So we've got time on the x-axis, distance on the y-axis. So we plot these points and we can see that we've got some different graphs here. This is a faster moving car because the slope of the line is greater than this. We've got a flatter line. This is a slower moving car. And then when the line is not straight, we've got variable or changing speed. So the slope of a straight line equals the vertical change divided by the horizontal change. Determine the slope. The blue line shown in the distance versus time graph. So we want to figure out what the speed is. So we've got, again, distance versus time. And I'm going to go through two different ways of doing this. There's a longer mathematical way, but a real quick and easy way to do this is if we've got 2 points that fall directly on that line, 2 intersecting points on a graph paper, we can say, oh look, I've got a distance, and we've got 2 units between 6, 7, 8, 9, 10, but how many boxes did I move in the distance direction? Because remember, the speed equals distance divided by time. So I've got 2, 4, 6 in my distance direction. Again, I've only got a change of 1 along this one. So 1, 2, 3. So I have 6 divided by 3. So 6 meters divided by 3 seconds gives me my speed. And 6 divided by 3 gives me 2 meters per second. I can do this the long way. So point 1 here is at time 1 second and distance 6. Point 2 is at time 4 and distance 12. And we can calculate by subtraction. calculate by subtracting these points. Sorry, it fell off the slide. So our vertical change, 12 meters from our top here, 12 meters minus 6 meters. And we've got 4 seconds minus 1 second. Oops, sorry. So we've got a slope, or a speed, 6 meters, divided by 3 seconds, gives us 2 meters per second. So, thanks for listening.